In this video, we're going to be talking about the parent function of the rational function and sketching a graph of rational functions. Let's start by first going through what are the 7 steps for graphing a rational function, and then we'll talk a little bit more about the parent function. So the 7 steps first would be to simplify f if possible, then find and plot the y-intercept, find the zeros of the numerator, find the zeros of the denominator, find and sketch any asymptotes, and plot at least one point beyond each x-intercept and vertical asymptote. And then use smooth curves to complete our graph. So the parent function of a rational function is f of x equals 1 over x. And what does this look like? Well, it looks like that. We've seen that before. Here we have a domain that is all real numbers except for 0. We have a range that is all real numbers except for 0. There are no intercepts. It's decreasing from negative infinity to 0 and from 0 to positive infinity. It's considered an odd function, and it has symmetry about the origin. The vertical asymptote is the y-axis, and the horizontal asymptote is our x-axis. So what do transformations look like? How can we tell which direction things move? So if we take a look at our parent function with the a's, h, and k's, you'll see that the transformations are the same as they were for the quadratic parent function and its transformation, as well as the absolute value parent function and its transformation function as well. So our negative sign in the front will reflect across the x-axis. Our a will signify a vertical stretch or shrink depending on the number. Our negative on the inside with the x will reflect across the y-axis. The number being multiplied by x will be a horizontal stretch or shrink depending on its number and reflected with its reciprocal when we are describing. The h will move either left or right. Again, when we're describing, we'll be using the opposite symbol. Or we'll see a minus, so we're like, oh, we're going to the right, and oh, we see a plus, we're going to the left. And then our k value will move it up or down. Up if it's a positive, and down if it is a minus. So notice that that's a familiar set of things that we're familiar with. So let's put that into action. So we're going to be sketching by hand and then comparing to its parent function the rational functions g of x equals negative 1 over x plus 2 minus 3 and h of x equals 3 over x minus 2. So let's begin. Let's take a look at a. So our g of x equals negative 1 over x plus 2 minus 3. It says reduce it if you can, and we can't reduce that. So we're ready to move on to our next step. So we want to find and plot the y-intercept. And our y-intercept occurs when our x value is a 0. So if we go ahead and we take our negative 1 and we plug a 0 in for x, and then add 2 to it, then minus 3, we'll get negative 1/2 minus 3, which will come out as a negative 7/2. So that's going to be our y-intercept. So let's see, y-intercept is going to be 0, negative 7/2. So we'll find that and then we'll plot it. So 1, 2, 3.5. So there's our y-intercept. Next we want to find the zeros of our numerator. And there are none because notice here that it's just a negative 1. There's no x value there, so we can't really do that. But our next step says to find the zeros of our denominator. So our denominator is x plus 2. So we can set that equal to 0, and we'll get that x equals negative 2. We're just going to kind of hold that for later. So we'll go ahead and put x equals negative 2. So that's going to be one of our zeros. And now we want to find our vertical and horizontal asymptotes. So this one's going to be a little bit different than what we've done in the past because of our minus 3 back there. So what that's going to change is our horizontal asymptote. So our horizontal asymptote is going to be that negative 3. All right, so that -3 right there is our horizontal asymptote. And then remember, to find our vertical asymptote, we take the denominator and set it equal to 0, which is what we did right here. So that tells us, because we also know that x is not allowed to equal to, right? And that's part of the domain. And so that tells us it's either a whole or an asymptote, and that's our asymptote. So now we're ready to make a table. But before that, we actually need to graph our asymptote. So let's graph our horizontal asymptote first. We'll go to -3, and we're just going to go ahead and put a dashed line at x equals -3. Should have probably written that a little more specific. X equals -3, because technically that is our asymptote. And for our vertical asymptote, we have a -2. So we'll draw a dashed line at y equals -2, which again, we need to make sure that we're writing the equation and not just the values. And now we're ready to create our table. So we'll create an XY table. And we're going to go ahead and start by looking at those asymptotes. So I want to kind of point something out, pause. This is the biggest mistake that people make, okay, is by getting those x's and y's switched around. Remember, if it's a horizontal line, that's going to be crossing at y. So our horizontal asymptote, let's go ahead and remove our asymptotes really fast. Our horizontal asymptotes are actually going to be a y equals. And our vertical asymptotes are going to be the x equals, because vertical means going up and down, which crosses at the x. So that's where we'll have our -2. So again, that's the biggest mistake that people make. So I wanted to point that out before we got too much farther. So let's graph our correct asymptote. So we'll have our vertical asymptote at -3, at y equals -3. And then we have our vertical asymptote at x equals -2. And now we're ready to go ahead and make our table. So we're going to put our vertical asymptote, -2 there, and we know that nothing's going to equal that, right? That's going to be an empty space. Now we're told that we need to have, come back up here, at least one point between and one point beyond each x-intercept or vertical asymptote. Now we don't have an x-intercept, because remember that x is actually not allowed to equal the -2 because it's in the denominator. So let's go ahead and pick a couple points. Let's pick a 0 and let's put our 0, and let's use -1. And then why don't we go ahead and do like just -3 and -4, and let's see what that gets us. So now we're going to go ahead and we're going to plug that in. We can either do it by hand, or we can use our graphing calculator to get our answers. So I'm going to go ahead and pull up my graphing calculator to get our answers. So we're going to have, let's see here, let's do this really fast. All right, so we've got -1 over, oops, that's a 0, -1 over, we're going to plug in a -4 plus 2, and then move on out there and go subtract 3 and hit enter. And we're going to see that we're going to have a value of -5 halves. So -5 halves is a -2.5. So -2.5. And then we can do the same thing, and we'll put a -3 in that spot. So I'm just going to go ahead and have it type it for us. And I'm going to arrow over and put in my -3 and hit enter and get a -2. So we'll put in -2, and we'll do it again with a 1, a -1 rather, and hit enter and get a -4. And then when we use a 0, that is going to give us, oops, let's try this, there we go, a -7 halves. And a -7 halves gives us a -3.5. So -3.5. So we're going to graph those. And so we have -4 and 2.5. And then we have -3, -2. And then we have -1, -4. And we have 0, -3 halves, which was our y-intercept. And so now we're supposed to use smooth curves. So I know I'm supposed to go close to my asymptotes but not to touch them, and that helps me with my shape. And I know I'm curving here because of the parent function. And I'm now done sketching this. So why don't you try to do letter B on your own? As a quick note, note that there's not a -3 or something back here, so our horizontal asymptote won't use that. So go ahead and try it on your own, see what you get. Push pause, and then when you're done, push play, and let's see if you're right. So my y-intercept, when I put a 0 in right there, is going to be -3/2. So that's my y-intercept. For solving for x, I get x equals 2, which of course we know that that means that x really isn't allowed to equal a 2 because it's in the denominator. That's where I got that from. Finding my horizontal asymptote, because there's not a number back here, then I'm going to look and I see that my x on the denominator has a larger degree than the one on the numerator. So if I were to rewrite this, I would write 0x plus 3 over x minus 2, and that would be a 1x, and 0 divided by 1 is 0. So I'd have y equals 0 as my horizontal asymptote. For my vertical asymptote, that's going to be my x equals 2 here. And so now I'm going to go ahead and graph my asymptotes. So I have an asymptote at x equals 2, and I have an asymptote at y equals 0. And now I'm ready to make my table. So maybe 5 points. I'm going to go ahead and take my vertical asymptote because I didn't have any zeros, and which makes sense because if I have a horizontal asymptote at 0, it's never going to cross my x-axis. So I know at 2, I am not going to get anything there. And I'm going to choose the points 3, 4, and 1, and 0 to plug in. Now I already know that when x equals 0, my y is a -3/2 because that's my y-intercept. So I'm going to go ahead and use that point, which I've already graphed right here. And then I'm going to go ahead now and I'm going to plug in the 1. So I'm going to have 3 over 1 minus 2, which gives me a -3. Then I'm going to go ahead and I'm going to plug in not the 1, but the 3, and that's going to give me a 3 over 1, which is a 3. And then I'm going to plug in the number 4, and that's going to give me a 3/2, which is 1.5. Now I'm ready to plot my points. So I already have my 0, -3/2 plot, and then 1, -3. I'm going to go ahead and plot that. And if I want, I can go ahead and graph that now. Make sure I use my smooth curve and get close to my asymptotes, but don't touch them. And then 3, 3, and then 4 and 1.5. And again, I've got a nice smooth curve and come in close to my asymptotes, but don't touch it. So that's an example of how to sketch by hand and compare. So the one thing that we haven't done is compared this to our parent function and how it looks different, because our parent function, remember, is here and here. And so in our first graph, we see that it's a reflect across the x-axis, and we know that because of the negative sign out in the front. The h has a +2, so that tells us it's going to go to the left 2, and a -3 in the back, so we're going to go down 3. And so that is our description of graph A, how we compare it. Graph B has a 3 up here, so what that tells us is that we have a vertical stretch by 3. We have an h value. It's going to take us to the right 2, and there's no k value back here. And so this is going to be our description of h of x compared to our parent function.